Hi, I'm Edmund Martelli, and I am here to provide a lesson on an outdoor enhancements for stormwater control. This is an Autocad GPS map. It's built on global information systems, process data, and this is a short, small area um, somewhere in the United States that has stormwater pollution, and we're trying to prevent pollution of the stormwater. Some basics about using AutoCAD and GIS maps, GPS data, is that these contour lines basically work on elevation. So in other words, this line and this line are different in elevation. This line here, the second one I clipped, the one that just turned green, actually they tell you the elevation of that line, which is 525. So anywhere across that line, you can expect that terrain to be about 525. Sometimes they vary. See, that's 517 there, and you've got, what, 18, 19, 20, 21, 22, 23, 24, and 25. So in other words, just by simply counting and subtracting, you can figure out the elevation between lines. So they're about a foot apiece, but you do need to verify that on occasion. So looking at this map, we can validate that this is an embankment, and this is a wetland here. And what happens is, when it rains in this general vicinity, these wetlands fill, and they stay wet for a while. Kind of like a marshy area. Good for greenery, good for vegetation. Good if you wanted to use as drinking water. So, based on some of the videos that I've been watching on sustainability, and especially for drinking water in low content areas of rainwater, such as deserts, what I wanted to do was develop a short CAD lesson on how to possibly implement such devices into these areas so that there may be clean drinking water, and maybe you don't want to use it for personally drinking yourself, being that you might require a distillery, but maybe you have some animals that this water would be perfectly natural for them to drink from. So over here in this map, you can see there's some woods, and again, this is another basin, like a little basin here. Maybe not so much a wetland, but more or less like a basin. And you've got the woods there. Of course, that's probably at a higher elevation. There's some type of building here. And this is a gravel road that runs along it, along this wetland here. So basically, this hatched area here that looks like sand, it's an ISO sand hatch. It's basically your wetlands. This is like a detention basin. There's some woods, there's some more woods, and there's a road that runs along to different buildings. Wherever else it goes, we're not too sure of. Now, there is one other major thing I noticed in this drawing, and it's been some years since I've looked at this drawing. But there is some riprap here that's erosion control. That's to keep a washout from occurring. But one of the other things I noticed was this silt filter fence that they have running along here. And that's what they're trying to use to keep pollution away. So you see, basically what's going on is they've got these trails or roadways here. Well, that's a pond outlet. And they're trying to filter it as it crosses along here. Being that this is an even lower elevation until it drops down in this detention basin. So it might be possible to take this area of wetland and detention basin, and to take this area of wetland and possibly put some stormwater traps in there, as I've seen recently on some of the videos I've been watching about sustainability and water harvesting, what they call water harvesting. So we're going to try to include an outdoor enhancement in this CAD drawing somehow. Architects and engineers rely heavily on mathematics. They tend to quantify everything. and they try to explain phenomena through scientific experimentation, things like that. So we're going to take something that we know about, and we're going to try to harvest some of the rainwater off of here to be used for maybe irrigation, or, you know, farm animals, or possibly even drinking water. So this is the first part of that video, and thank you.